Hello, welcome. Thank you for attending to our presentation.
Yes, so welcome. Thank you all for coming. It's Thursday, 2 p.m., so it's good to see many faces still active. Yes, I'm the managing director of Survision in the United States. So the idea for today, we brought two profiles, completely different. I am more in sales and marketing, and Jerome, who is our chief product and technology officer. Because the idea is to really talk about what we want to do, what we want to succeed with a technology, and then what the technology can really do.
So let's start with the agenda. First, we will try to understand why the license plate recognition needs to evolve. What do we need to do things differently? And then we will talk about vehicle recognition and not license plate recognition. And we'll try to explain what does that mean.
Yes, so we want to also show you some real-world examples. So you're going to see some plates, some things that happen on the field, so a real operation. And then maybe guess what happens in the future, like what can we do now with this new technology and how we can adapt the technology to be prepared for the future. So the first slide is more like theoretical. So parking is changing. I don't know if you were here this morning, but there was a presentation about the digitalization of parking, which we all know, the driver experience. All of us here, we all work for the driver. So the driver is the client of all of us. We see that the driver's expectations have changed. And when we say they have changed, it means that we're expecting something of all of us that is effortless. We talk about ticketless, gateless, frictionless. I don't know exactly what is the solution or what the solution will be, but the important thing is to be effortless. So I'll give you an example. I was at Harvard University some weeks ago, and the parking attendants there have been there for generations of students, and they were saying that they are having a hard time right now because students don't want to do what they have to do. So before it was very easy. You will tell them, go to the office, fill a form, get a parking permit, put it on your vehicle, and then you go and park. And today, unfortunately, they don't want to do that. So the students will just say, what? Why? I'm not going to go to an office. I'm not going to stick a paper on my car. I just want to stay here with my phone. So everything is about giving the right technology so they are allowed to do that. So they can finally, all of us, we can just go where we want to go without minding about parking permits or parking payments. So that's the goal. What do we do? So since we are on the technology of reading the license plates, we have to help all people here to succeed in providing that. So we have to see what happens when we have identification errors that doesn't allow us to go and provide that effortless experience that we want to provide. So what are we going to do? So why it matters now? It matters now because we are trying to get ticketless. We talk about ticketless, everybody has some sort of ticketless solution. Then when you are parking, most of the time you have a ticket. So the idea is to see why there are still some limitation, why not everybody is doing that, why not everybody is providing that solution. It's probably because it's not 100% effective. So today we are going to talk about a system that is helping to improve the limits.
Okay, this is non-conventional way of doing a presentation. Usually like you were saying, Laura, we like to talk how good we are. But here we have to admit that there is some limits with the traditional, what we call the traditional license plate recognition. I have some example for you. So if you switch,
brought some good examples from the US.
Yeah, you love the US, Laura, so yeah. That's why we choose the US. So The real life is the plate is not always fully visible. It's here it's some real examples. So the first one, you can see one plate which is hidden by a trailer. So depending on the point of view of your camera and depending of where you will position, and along the side you will see part of the plate, the full plate, or the other part of the plate. The second one is a similar example. It happens quite often. The third one is a typical reflection due to a plate which probably has been damaged at some point. So it's also a reality, and it affects the license plate reading. This one on the bottom left is also interesting. So I don't know if it has been done on purposes or not, but the plate is upside down, so you can try to read it upside down. It's up to you. You can try. And the last one, we are still in winter, not for many days, and the reality is the snow can pack on the license plate, and the plate can be partially hidden. So this is the reality. And on top of that, you also have the reality of the installation. So of course, we always try to have the best possible installation, but you also have to deal with the constraints. So sometimes you have to deal with a specific curve. You have to deal with a limitation because you have a road behind, because the reality is not perfect. So you have to deal with that. And what do? We just say, okay, never mind, we don't care about the vehicle, or do we try to do something with that? Usually, and the industry, to try to solve for that, has implemented what we call a N-1 strategy, or Levenstein distance for the people who know about that. What does that mean is you accept that you can partially read a plate, and you say, okay, maybe instead of ABC 123, it's ABC 124 or something like that. It can work, but it fails. It fails because we have fleet vehicles, and often these fleet vehicles have sequential plates. So you really have vehicles, we are close to each other, with one digit difference. It's a reality. In big sites like airport, university in the US, the probability to have two vehicles with almost the same plates, including the states, it happens every day. So implementing an S-1, it's gonna fail. And the bad thing is when you fail, you're going to do not one error, but two errors, because you're gonna propagate the error you have been implementing. So now, just to mention a buzzword AI, but the idea is to see how the technology can help, how we can try to overcome those limitations, and how we can try to overpass this limitation, not only with the license plate reading, but on top of that, to adding some new stages and new implementation.
Yes, so we call it a shift. It's a shift because it's changing even the name of our technology, the name of what we do every day. We always talk about license plate recognition, and today we believe that we should start talking about vehicle recognition. We cannot just stop at the plate. We have much more information on that image, on what we are capturing, that we can take advantage of. And again, what is very important is not just, grabbing data. So it's like, oh, now I'm gonna have all, make, the model, the color, like all the information, and just provide it. The idea, and what is very innovative right now, is how we combine the data. So exactly like AI, I think all AI for us is like, for many of us, is like ChatGPT. So to give you an example, when we were searching on Google, you will ask one question at a time, correct? Right now, you can have an entire conversation. So this is what we are saying here. Like, it's not just providing the plate and more information, but it's combining all of that to be able to recognize a vehicle, even if the plate was not perfectly read at the beginning. So this is what we mean by vehicle recognition. It's a multi-layer identification. So it combines, and again, the important thing is the combination. It's not just providing the data. Nobody cares how many red cars you have in the parking lot, like maybe my son. So you have a license plate, the make and model, the color, the category, all also the visual features that we get on this image, the fingerprint on the plate of a vehicle. There are so many things that you can grab on an image that you can capture. And all of them combined create a vehicle ID that we can recognize, and then we can match between the entrance and the exit. And this is where we think we can really create an evolution in the technology and overcome some of its limits that we were showing. So what changes when you add context? What if we go from license plate recognition to vehicle recognition? What can we are overcoming the limits, and what is the result? So the result is that we're going to have a higher match confidence. And in parking, we all know that the matching rate is so important, because you can have a high accuracy rate at the entrance, and if you don't have a good matching between the entrance and the exit, it doesn't matter all the plates that you capture. So the matching rate is very important, and with this you can have a higher one. You have fewer false positive, you have a stronger fraud detection, because you're also able to detect a vehicle even if they're trying somehow to hide the plate. And so you have a much more reliable automation. And that will allow to finally provide the better parking experience that we want to give all of us to the drivers.
Okay, so let's have a look in details. What does that mean? So here I'm having my entrance. Here I'm having my exit. So like Laura was explaining, the game consists in collecting above the plate additional information which gonna help to identify the vehicle and to recognize the vehicle. So having those information on entrance and on exit, now we are able to combine and to improve and to create a specific logic within this architecture. And then at the end, even if we don't have a complete plate, even if we miss some of the information on the plate, we are able to say, okay, this is the same vehicle transaction. So looking for, if you go to the next one, for a real example, so I'm going back to the N-1 example. So here we are in a big airport in the US, you have recognized, and the first image is the image we got on the entrance. The two on the right part are the images that comes from the exits. And you see that if you just look at the plate, I don't know if you have a good view or not, but you'll see that the plates here differ on one digit. Okay? So if you implement a N-1 strategy, when you see this vehicle exiting, if the real one has not exited, you're gonna say, okay, my transaction is done and it's finished. And you're gonna do an error. Thanks to this specific matching, having taken into account all the possible information we have collected, we are able to say, no, this one is not the correct one. I have to leave it in my park, I have to let my transaction open, and when I really see the vehicle, I see, okay, now I'm able to say the transaction is complete. This is another real example. We call it the Zongo example, but maybe it's not really a Zongo example because we don't really know if it is a O or 0. It's a vanity plate, so it can be both. And you can see below that alternatively, we may read one or the other. So again, if we just look at the plate and depending on what it is, here we see that we have seen enter the vehicle. We have seen it with a 0. It was almost noon on the 24th February. But as we have read something different, we may say, okay, I have two orphans. One is the entrance one, so I think it's still in the parking. And the second, we only have seen it on the exit. And hopefully, if we combine additional information, we don't care, and we are able to say, okay, this is a correct match, and we can close the transaction properly. And the other information which is interesting here is this plate is a real example, and it's an employee. So this guy is coming again and again, and if you don't have a correct matching, it means that every day you will commit the same kind of errors, and you will repeat again and again the same kind of errors. So this is really important to say, thanks to the added information we are able to collect, we are able to solve for those situations which are horrible as an experience, because repeating the same error again and again, I think it's the worst thing we can do.
Right. So that's really all about the technology, about the innovation, that how the technology is evolving and what we're presenting. So the idea is also for today, since we're all here to think about the future, is also see how we can imagine this technology being used to improve. So it's not just open like a parking lot with a gate. Here we're thinking of many more things, and we already see them. So we see with autonomous fleets, for example, we need to check their behavior. We need to be able to recognize them. We don't even know if they will have a plate in the future. So we have to start analyzing much more than the plate. We have to connect to the vehicles, we have to see all the image, we have to analyze all the data that is available and combine it. So the autonomous fleets are definitely something that we think are gonna be used with the vehicle recognition technology. Curbside management, this is a big topic. In the city of Miami, actually, we already started doing this. So they are charging for the curb. It means if an Amazon van is stopping to deliver something, they can charge them. So they use computer vision to be able to see that it is an Amazon product, and then they can pay with an app to use the curb. And that's very important because the curb is gonna become the new parking for everybody. Because when you have an autonomous vehicle, it's gonna just drop you off and go park by itself. So you see that the curb is becoming more and more busier. So that new pricing model, that's what I'm talking about, charging for Amazon or this kind of clients. About what do you think about the future?
On my side, I think if we want to go for a future world where we will have a lot of automation, where we want to automatize a number of tasks, if we don't have a very strong way to be able to say, okay, this is the same vehicle, it has stayed this amount of time, and I know from the information that has been collected that I'm sure it is the right one, we cannot go into that future. But having this possibility, then you can imagine this new business model. You can have smooth operation. You can avoid a lot of disputes. You can avoid a lot of manual review of the thing. So it makes it happen. So having something which is reliable is really important. And this is where we need to focus to make sure that this feature is possible.
So, well, thank you so much all for coming.
Thank you very much.